I'm going to be demonstrating a Haskell implementation of the C3 Linearisation algorithm. So when you have multiple inheritances classes, you have to resolve the order to look at methods. So with single inheritance, you look at the class and you look at each of its superclasses in order, and you find the first one that contains the method you're looking for in a simple linear search. However, with multiple inheritance, it's more complicated and the order has to be resolved yourself. So, let's look at class A, and that just inherits an O. So its MRO is just A then O. So when you look up for a method, it just looks at A and looks at O. That's simple, that's single inheritance. Okay, now looking at class F, that inherits an A, B and C. So this also uses a different rule that classes to the left, or that are inherited first, have high priority. So it looks at A, B and C, and then all of those inherit from O. So then it looks at O. So the MRO is F, A, B, C, O. Now with class I, it's a bit more complicated. So the method is we look for the first head. There's not a tail of any of the others. So our heads are F, G, and H. So we need to find which of those is not a tail of any of the others. So we look at F, that's the first one, and we can see that actually it is not a tail in any of the other MROs, and so it's a viable candidate. So we add F to our accumulated MRO, and then remove it. Next we look at A, and we can see that actually that is appearing in the tail of the third MRO, so it's not viable. So the next option is G, and we can see that does not appear in any of the tails, therefore it's a viable candidate. So if we remove that, and we add that to our accumulated MRO. Now let's look at how the algorithm is actually implemented. So we start off with this linearised function. So this takes a list of MROs and returns a single MRO. So we start off by doing a pass. So we check if this second element of the tuple entered is empty. So the first element of the tuple represents the accumulated MRO, and the second element of the tuple represents the remaining list of MROs. So we can see it's not empty, so we do a removal pass. So this removal pass, its purpose is to find the first head that's not in any of the tails, remove it from the all those heads if it's in any of them, and then we move that head to the end of the accumulated MRO. So first of all, we use this. We find first match maybe. So this is the first class, or the where pointer is an alias to a character. So we find the first class that's not in any of the tails and is also a head, and it's a maybe because there might not be any. So assuming that we did find something, it goes to line 43, and then it simply adds that head to the accumulated MRO, and then it goes through all of the remaining MROs tails, and it dequeues the first element of each one if the head matches the head that we found. Our dequeue-if function is very simple. We just simply take a head and we take a list, and if that list's head is the head given, then we remove it and return it. Otherwise we just return the original list. In the event that first match maybe is nothing, that means that we could not find a head that was not in the tails, so we could not find a class to append to our accumulated MRO. So what we now do is we uniquely concatenate every single element into a single MRO, and then we concatenate that with the MRO that we found. So in this case we find the head of the head, and then we prepend that to the unique concatenation of everything that's left. Now this dequeue delete if and the edit remove thing, what it does is it dequeues the head from all of the MROs that contain that element as its head, and then if the element left behind is an empty list, then we erase it entirely. And the reason for this is because we need to find the head ahead, there's a risk that we might have an empty list, so it means that every list is never going to be empty. So it's a simple recursive concatenation after that, and once we've done that, we concatenate the result back to our original chosen values, and then that leaves us with the entire arrow. So now that unchosen is empty, we simply return the tuple with the value that we found and an empty list. And now in our linearized function, since there's no longer any recursion, we just simply return the first element of that tuple, which is our accumulated MRO.